Hi, quick tutorial on how to answer one of these topic tests on global hazards, and we're just going to go straight into it because we're going to be a little bit pushed for time. So this question here says, below are 4 statements about a constructive plate boundary. Select which statements are false. So really, really important to read the question here. Almost made a mistake earlier myself. So which of these statements is false? Basaltic lava that comes from the volcanoes has a low silica content and has a thin consistency. Plates are being pulled apart from each other by convection currents. Shield volcanoes are formed, and the pressure created by the movements creates explosive volcanic eruptions. So, first thing that we would want to think about here, after reading those statements, is constructive plate boundary. Which one is it? So it's not this here, A or B. It's not a collision plate boundary, and it is not a destructive plate boundary, so the plates are not moving towards each other. It's not D. It's not plates moving alongside each other, either in the same direction or opposite directions like this. So they're not. It's not conservative plate boundary. It is a constructive plate boundary where they're moving away from each other. It must be that this is the false statement. So D is our correct answer here, or an incorrect statement, because the pressure made by explosive that creates explosive volcanoes occurs at A, destructive plate boundaries, which we're going to talk about down here a little bit later on. Basaltic lava is the fast-flowing but non-explosive lava that we get at a constructive plate boundary, where the gap opens up in the middle and there's not as much pressure applied. Shield volcanoes are formed from that lava cooling. Plates are being pulled apart, so going away from each other, convection currents. So it must be that D is the wrong answer here, and therefore is the answer that we put in our box. It is the false statement. So we get 1 mark for that. Explain how the movement of tectonic plates at destructive boundary causes volcanoes to form. Now, it makes most sense here to tell a little bit of a story and start off by saying, well, the plates are being moved apart. I'm not going to write in full sentences here, so you would need to put this into full sentences. That's going to get you 1 mark. It's going to get you your mark for your kind of your idea here by convection currents. That if you develop that a little bit and say it's moved by the mantle, actions in the mantle called convection currents, which are our magma moving around underneath the surface of the crust, we get a development mark here. Okay, so after we've said that, we can then say that there's going to be subduction taking place, which is where one plate, which is heavier, will go beneath another plate, which is lighter than the heavy plate. So subduction occurs, meaning that there's this sinking oceanic crust. That's going to be another mark for development point. And finally, we can say that this leads to a melting of the heat in the mantle, so melting of crust in the mantle, and that's going to force its way through the cracks of the rock. So it's going to go through the rock above it, through rock in the either oceanic or continental crust, leading to a volcanic eruption and eventually a volcano forming. So it's going to be our final mark for development. And it's going to be simple as that. So 4 marks. Next page, we've got give 2 types of extreme weather associated with tropical storms. Now, if you remember the structure of a tropical storm, I'm going to do an aerial view of that tropical storm. We've got wind moving in one concentric direction, so in a circle, right, as a result of a number of factors, which we don't need to name here. We've got these bands of rain, 3 bands of rain usually that occur with more dry and high pressure conditions in between them. So we have high pressure here, low pressure here, high pressure here, low pressure here. Rain associated with low pressure, rising air and then cooling and all of that. And we've got the eye in the middle. Very strong winds on the outside of the storm, and as well as that, we've got very, very extremely rainy conditions here. So what we could say here is we're going to have strong winds, strong, consistent winds. Okay, got in brackets here, but strong winds will get us the mark. Consistent winds is as in consistent winds to make the rotation possible. And then for our other mark, we want to talk about rain in some way, so we're going to say extreme heavy rain And you would also get a mark here if you said something like lightning, which would occur as a result of the storm. It was a tropical depression, getting big enough and with wind speeds high enough to be considered to be a tropical storm. Okay, now finally, this big question here, and I do have a blank fill to go with this for when you attempt this yourself at home. So we're just going to box our command word asking us for a balance of responses, right, balance of positive and maybe limited responses associated with an extreme weather event that the UK, extreme natural weather hazard that the UK has experienced. Or sorry, this one doesn't even say extreme, but we're going to discuss a relatively extreme weather hazard in drought. So drought is going to be our case study. 2012, and it is on pages 26 and 27 of your textbook. You need to have a look at that information later on. Talk through a little bit about how we need to make sure we answer this question. So our natural weather hazard is this one up here when we book our question. We must refer to the UK. If we don't at least refer to the UK once, you will cap yourself if you do not do that. And finally, you are not discussing in any great detail factors that cause the weather hazard to occur. You can briefly mention that at the start of this, that this was a weather hazard that was associated with an extreme change in rainfall, and we can in fact bring in some data that reflects that, but the data is going to be linked in some way to a response that we've got. Okay, so we are talking about the responses, how the government, how locals and regional areas responded to this, how companies did it, how any group of people responded to the hazard itself. So we've got a couple of ways we can break this into content. So the responses themselves, one of the responses was an extraction of water, and this was done either by government-led companies or government-hired companies. So the water was extracted from rivers, and this was in order to fight wildfires. A really, really important response in some ways, because of course we need to prevent destruction, which we'll talk about later on, of migration routes for animals, and things like making sure that we didn't allow forest fires to extend all the way to farmland and things like that, to prevent, which would have economic impacts. So one was, and this was a government scheme to allow for the extraction of water from rivers to fight wildfires. Companies also got permits to do this. So permits allowed by government. So the government assigned certain companies the possibility to actually extract that water from rivers. And then another couple of things that we can talk about here are hose pipe bans. Prevented people from using hoses in their gardens and to wash their cars and things like that. And this obviously affected families, mostly families and people living in their own home. And finally, there was a campaign for people to use less water. Campaigns would have been local, regional, and there was also a national scale campaign. Right, so those are the responses. Those are three particular responses that we can touch on. And then evaluate. So we need to then discuss how these things here either had positive or negative consequences. So one of the positive consequences for the hose pipe bans, for example, was that it allowed for more water. So more water due to hose pipe bans available to treat severe incidences. So available for essential purposes. It would also mean that there would be less water necessary to take from rivers, which is going to be important for, keeping the soil very fertile, and keeping rivers at the depth that they are, so that we don't slow them down, for example. And then a negative, we could say here, that people's short-term health might have suffered from a lack of hosepipe bans, because maybe, for example, they get food from their garden, or maybe they are getting in cars that are very dirty and dusty, and that's going to affect their health in some way. There's also going to be people's health affected in other ways, but people's short-term health affected. Not just by this, but also by the fact that there was a campaign to use less water, so people were trying to use less water while brushing their teeth, so affecting their hygiene, using less water, for example, to then go and boil their kettle, so they're drinking less water, staying hydrated less, and so on and so forth. A couple of other positives that you can bring in here. Migration routes of animals were protected in many areas. But then, of course, in order to do that, we had to extract water and use that water. Firefighters putting out fires all across the country, and this meant that water levels and water depths in rivers were lower, and that would have an impact on local animals and vegetation, so damage to those. So, like I said, there's going to be a blank field that goes alongside this video, especially in our interventions after school. I hope this helps kind of fill in a bit of the gaps associated with our Global Hazards unit, and if you've got any questions or any particular question that you would like me to tackle in the video, please do let me know and I'll get onto that.